sessions interactive. Thank you. I expect the same in this session. I'll try to finish it as soon as possible. I think you have learned a lot about these technologies in much more details. And as most of the people are from technical background, I think they know iron making technologies better than us. So let's run through these slides. If anybody has some doubts or any questions, you may ask. Then in steel production value chain, iron making is the most emission intensive step. While low emission steel making, electric arc furnaces promises a low emission steel making route with use of scrap. So for that, low emission iron making technology is also required, or technologies are also required. So these technologies are different stages of development. Some are at very high TRL levels, some are at low, some are at lab scale. But in the long term, we can expect few technologies will develop and will be commercially viable. So this presentation will give you an overview of these technologies. Then Ministry of Steel initiatives, I think we covered it in previous slides in much more detail. There are various initiatives by Indian steel players. Tata Steel, CBM injection, hydrogen blast furnace, their net zero target is 2045. JSW Steel, again 4 million ton low carbon steel facility by 2030, allocated a large sum to renewable energy and the target is 2050 as in public domain. Then AMNS, they are targeting 10% scrap utilization. Then for environmental initiatives, they had allocated 273 crores. Net zero target is 2050. JSPL, coal gasification for TRI production, it is their unique plant, and they are targeting net zero by 2047. Jindal Stainless Steel, JSL, they have set up first green hydrogen-based unit in ISAR, and they are aggressively looking for renewable energies by 2050, and by 2050 they aim to become net zero. SAIL has declared to be net zero by 2070 as per the national targets. And then Kalyani Steel, they have made a very low emission intensive steel using scrap and RE. So that is Ferresta and Ferresta Plus. These are their products, and they develop it for the international market, basically for exporting. And they have, of course, higher returns. Then this is the summary of the technologies which I have in my presentation. The existing process is blast furnace, through shaft furnace, basically a natural gas based routes. Rotary kilns, coal-based DRI plants, which are prominent in this eastern region and again in Bellary region, the south. Then direct electrification, their TRL levels are low, gold monoxide electrolysis and low temperature electrolysis. Some of the companies like Electra has developed low temperature electrolysis, but it is not at commercial scale. Then hydrogen, shaft furnace, fluidized bed, rotary kiln, plasma reduction. I think these have been discussed in detail in previous sessions. Biomass based reduction and biochar furnace. These are at high TRL levels in some of the countries like Brazil. They are using biochar at large scale for iron and steel production. Then CCUS, they are demo scale plants even in India. Then shaft furnace based NGA, again in India there is an example, JSW owns that. Smelting reduction with coal and CCUS going forward. This also provides a promising solution for low carbon iron production. Then here are the ore and ore processing requirements for these processes. In iron making, what are the reactors or furnaces being anticipated or are being used? Then in steel making, what kind of furnaces will be required, maybe existing DOF route or the electric arc furnaces. Technology technology readiness level in concept, initial idea, application formulated, and concept validation. Then small prototype is 4, large prototypes at 5 and 6, demonstration scale is 7 and 8, early adoption is 9 to 10, and mature is 11. Do we need to discuss these?
No, not really.
Yeah, these are only thing I think the TRL levels you may see golden MOEs at 5. Suitability to India is medium because of various factors. Scale of production is main. Low temperature electrolysis. Early large prototype. Suitability to India is medium. It's not that high. Hydrogen shaft. Yes, suitability is high considering the Indian conditions. Then fluidized bed. Again, suitability is high. Early prototype is there. Emission reduction potential is also high. Rotary kiln. This is something new. Rotary kiln is a new concept that is especially for replacement of small coal-based DRI units. So in this small furnace, it is under implementation in Namibia, and I think the plant is under commissioning and will
What
start.
can be the maximum capacity in this rotary kiln?
You see, 800 TPD is the maximum anticipated, but the existing, the project I am talking about is 50 TPD kiln, rotary kiln, and its structure is also different from what we see in the general coal-based DRI units. So it's a heating mechanism, and then hydrogen is injected.
High electricity consumption.
Sorry?
Electricity requirement will be higher.
Of course, normally you heat the raw materials. Then suitability is high because it may require low capex, and it will be suitable for various needs in India. Then plasma smelting reduction, I think bundles are discussed in detail, and these are just a glimpse of that. And suitability is again medium in Indian case. Then biomass based reduction. Although we produce a lot of biomass in India, but the challenge is getting the aggregation of the biomass and suitability for steel industry. These are the two main factors. Although power plants also have a mandatory obligation to use biomass, they are not able to meet the requirements, but government is still hopeful of aggregating this biomass and find the suitable biomass for specific industry. For example, iron and steel requirements may be met by bamboo. So the bamboo availability in this region may not be that high. So if we transport it from northeastern part of the country, then the cost will be high. So, but now the government is trying to matchmake the biomass available in the local region with the industry, so that it can be available sustainably. That's why the suitability is medium. But yes, some of the operations can have biomass as the raw material. And biochar in the blast furnace. Brazil is using a lot of biochar in their small blast furnaces. As PCI as well as they are using a bit of biochar in coke making as well. It is possible, as per the experts, industry experts, some of the blending can be done in coke making, in PCI, as well as some of the coal can be replaced in cement making as well. Suitability is medium, technology readiness level is 9. Then blast furnace with CCUS. Blast furnace with CCUS. Emission reduction potential is low, but since it is more than 60%, yes, it is significant emission reduction is possible. Large prototypes are there. There are some of the MOUs between Indian companies and technology developers for this kind of solution. Suitability to India is medium, but this could be a possible measure for low emission iron production at scale. will have to capture, let's say a blast furnace producing 10,000 tons of hot metal per day. So the carbon capture requirement will be huge, and those plants are, require a lot of energy for capturing carbon, and the carbon produced either in liquid form or the dry ice. Keeping that in that state is also a difficult thing. So let's see how things develop. 100 ppd or 5 ppd CCU unit in Jamshedpur is not enough. And consumption, we are also not able to match make or CO2 producers with CO2 consumers. Although demand is there, but not match making is required. The natural gas shaft furnace with CCUS, whatever the gas comes out of the shaft furnace can be utilized, captured and utilized. I think, sir, that's what JSW is doing in Salem plant.
It's about hydrogen, not natural gas.
In HY, in the existing plant. Okay.
Existing plant has already got hydrogen going into HDR.
Okay, so from where this carbon is captured?
There is no carbon capture. There is no carbon emission. We are talking about hydrogen DRI.
But in the existing
There will
facility,
be few more modules added which will make it to 4 million.
that is fine, sir. But JSW has published that they are capturing 100 tons of CO2 per day, and it is being utilized in beverages.
I have no idea.
So what I know is that it is a HYS technology-based plant in which natural gas is used, and CO2 is captured and then bottled, sent to bottling plants for beverage bottling plants. Suitability to India is low, high cost of energy-based plants, and again high cost of carbon capture. The smelting reduction CCUS, again a different version of smelting reduction furnaces with carbon capture unit. Its also suitability is also easy of assessment to India. ERL levels are set up, the commercial demonstrations were there. Then we have to scale up the priority technologies which have high suitability to India, and mid to long-term R&D focus is required. I think the government has taken the steps in right direction, but more incentives or more policies are required for enabling this R&D and to develop Indian technology. Then electrolysis innovations will be an ultimate step where we can reduce the energy consumption, and our challenge of low-grade iron ore will also be catered to this electrolysis innovations. Then biomass reduction is a short-term measure, but as we discussed, a lot of efforts are required for biomass producing thing and consumption centers. Then CCUS integration needs evaluation, whether it is in favor of the country, it is in the favor of producers or not. That also needs a thorough evaluation. That's it from my side. If you have any questions.
Very nice. After a marathon day, or rather days, we are attending this. And the good part is that what I saw today in the previous presentations, most of the topics are already covered. So very little to be covered, and I'll try not to repeat something that has been done already. So I am representing Switch On Foundation. Switch On Foundation works a lot on sustainability, distributed renewable energy, also on the agricultural side and all. So we are right now working on a project which is low carbon steel, and we will be sharing some of the perspective This is an ongoing project. Some of the perspectives on the interventions and challenges. The primary purpose of the project, as you will understand, is to address the high carbon emissions of steel industry, and we are looking at both the production side as well as the consumption. Now, and we are primarily focusing on the MSME sector. I understand from here all of you are from, of course, the large-scale industries. But this particular project is more on the MSME, but the solutions are overlapping. Okay, the similar solutions. The focus areas, something that we are focusing more on something that, since it is MSME, something that they will be in a position to kind of invest and actually work on. What are the doables? And there are certain things which are, we'll talk more about the short term, and certain other things are in the medium to long term. So the areas of focus that we see are more practical. They include the renewable energy, scrap steel, energy efficiency, low cost financing, and in the medium to long term it's the hydrogen, carbon credits, and the car CCUS technologies. Now these data I will not repeat. We have seen this several times. And the only thing that we'd also like to kind of highlight over here is that while we are talking of decarbonization, which is a necessity for human survival, which is a necessity from our 2070 kind of goal, but it is also a necessity to survive in the business, because in some of the things like CBAM, etc. is coming up, which is pushing us towards compliance of that. Otherwise, we might be losing market. The first part is renewable energy. I'm sure all of us know that this reduces carbon, and therefore this is a very good opportunity to actually implement. But at the same time, all of us also know that there are certain problems of renewable energy. For example, it's not available 24/7. And even within the day, it varies. It's not constant. But my consumption is constant. Alright, so we have that problem. On the opportunity side, the cost of renewable is low under certain circumstances. Basically, the production cost is low, but there is story beyond that. We'll talk about it. And also, renewables, according to studies, renewables can cut scope 2 emissions. We were just talking about scope 2 emissions in the previous presentation. It can stabilize cost because when we are using grid power, although it is stable in cost, but every year it changes. But if we go for renewable energy, for many years it will be kind of constant, because the initial investment has been done and the repetitive O&M cost is much lower. And also it will enable future electrification of not only EAF, and we spoke so much about hydrogen, and for that it's a particularly a necessity. But the problem is about renewables is how do we get it? If you look at West Bengal, in West Bengal there is a regulation or there is a tariff which says that you want renewable, okay, you get it. WBSCDCL will give you renewable power. I don't know about DVC, but WBSCDCL, if you pay 50 paisa extra, you get renewable.
Same with the DVC.
Same with DVC, right? But then that becomes costly. Then that doesn't actually, unless a business meets its financial objective, it can't work. It just can't work. We all know. Now, so if we go for solar rooftop, then in case of solar rooftop, what happens? If we have the net zero method of billing, then this renewable energy makes most sense. Because if I can generate solar energy on my rooftop at 3 rupees or 3 rupees 30 paisa, 3 rupees 45 paisa, compared to that the grid cost would be 7 rupees, 6 rupees at least, it makes sense. Alright, but as long as we have net metering method. But unfortunately in West Bengal, that net metering method is applicable only up to 5 kilowatt. Beyond that, it's net billing, and net billing practically from the finance point of view does not make sense. Alright. But then in Jharkhand it is possible, in many other states it is possible. So that option is there. The advantage is that you can utilize your unused roof area in the minimum land impact, and you can reduce on-site generation. That is, the transmission losses are also minimal, almost zero. But on the challenge side, is that depending on the rooftop area, you can generate. If your consumption is more than that, then to that extent you get restricted. And wherever net metering is not there, then that's a problem. Now if we want more renewable energy compared to what my rooftop can give me, then what do I do? Then we have two different methods to go forward. One is the green energy open access, another is the captive power plant. Captive power plant of renewable energy. Right. Now, if we go for GEOA, Green Energy Open Access, this is a rule by the central government, and any industry which has a connected load of 100 kilowatt or more can get this opportunity. They can purchase power from anywhere in India. You are sitting here in Durgapur, your industry is here, you can purchase power from Rajasthan, or for matter anywhere. So if I look at a grid scale production of renewable energy, maybe today it might cost 2.57 rupees per unit, which is much lower than the grid cost. But the story doesn't stop there. What happens? There are a number of other charges that get applicable on it. One is, if in Rajasthan, I am taking the example of Rajasthan here, if it is connected to the distribution network, then distribution billing charges, then the power goes to the transmission network, transmission charges, PGCIL charges, thankfully PGCIL transmission charges for this case is zero. Then it comes to West Bengal STU charges, West Bengal billing charges. So many transmission charges gets adds up. At every stage there will be losses, that cost of losses will add up. Then at the receiving state point, that is the state of West Bengal, the cross subsidy surcharge will add up. In WBACDCL at 33 kV level, the cost of subsidy surcharge is 1 rupee 4 paisa. That straight away adds up. And of course there is one more, that is additional surcharge. There are so many surcharges and charges. So one needs to make a conscious decision whether it is making sense. If the cross subsidy surcharge is low, in most cases it still should make sense. But one needs to do the evaluation. Now, since cross subsidy surcharge is a problem, how do I resolve it? One of the way is to go for captive power plant. If you go for captive power plant, according to the regulations, the cross subsidy surcharge will not be applicable. So for the West Bengal case, straight away you are saving 1 rupee 4 paisa. Alright. So, but if you are doing a captive power plant, there is an investment required. There is a way out also in this case, that if you are creating a captive power plant, it's not necessary that you have to invest 100%. If you are investing 26%, you go to in a joint venture mode, 74% somebody invests, and whatever energy is produced out of that plant, 51% of that you should consume, then you get the CPP tag, then you are saved from cross subsidy surcharge. So these are the various ways of getting a renewable energy. There is one more way which is called behind the meter, which is not a very formal or very informal way of procuring power. The places where net metering is not allowed, some of the customers are going through that route. that it's like you putting up a generator in your backyard. Instead of a generator, it's a solar power plant. As you generate power, it's equivalent to net metering as long as you are generating and consuming simultaneously. But the problem and the comparison to net metering method, the BTM method, the problem is that if there is extra power generated compared to what you consume at that point of time, you lose that power altogether. In net metering method, what happens? That power goes to the grid as if it is banked in a grid, and when you need that power, you can draw it back. Here you lose that power. So comparatively, BTM is not that attractive compared to net metering method. So overall problems related to renewable energy today are the net metering method is not very standardized. For solar rooftop as well as for captive, as well as for behind the meter, it's capital intensive. Then there might be site constraints, roof space, land space that might be constrained. There may be shading problem. Then the other thing is that in any case you need a grid backup, because at night you need grid power. Whenever there is fluctuation you need grid power, and that backup has a cost. Then technical gaps, because the steel industry, the people over there, the employees and the specialists over there are experts on steel, not on power. So that knowledge gap comes in, but of course one can outsource the entire work. Of course that will also have a little bit of cost. So in this case, one needs to look also at ESCO model, wherein the third party invests for the renewable energy, and on the basis of savings, whatever is the saving, that saving is kind of shared between the two parties, and it's a kind of a win-win model. So it's working in some area, it's not very popular because of the related risks for the ESCOs, but if it works out, it's a very good model to look at. Then of course we need low cost financing, in other words green financing, that is required. Government may consider compensating for the cross subsidy surcharge, because that's a big hindrance in implementation of green energy open access. Net metering standardization will be required, and capacity building for that matter. That is related to renewable energy, and renewable energy is something that is doable today, and it is very important for all industries, particularly I would say the MSME industries, to look at it more seriously to reduce their costs. Now coming to scrap. Scrap, my colleague Mayank has discussed a lot about it. A few points on this I will add here. 1 ton of recycled scrap saves 1.1 ton of iron ore, 0.63 ton of coking coal, 55 kg of limestone, 58% reduction of GHG emission, 40% water saving. So scrap is highly useful. Now in 2019, 332 million metric tons of scrap was used, out of which 25 was the domestic scrap. But as discussed earlier, a lot of this scrap, this 25 is actually more, but that data is not here because a lot of scrap actually transacts in the informal market. And it's very difficult for the formal market to compete with the informal market. Why? Because labor conditions, they don't care in an informal market. They will take up, if a end of life vehicle comes, the mobile will be taken up, they can be dropped anywhere. It will seep inside the soil. If they reach underground water, it will pollute. They won't care. And also, the scrap gets mixed up. The way of segregation at source doesn't happen properly. And as a result of which, we were talking to some MSME industries, they're saying that the scrap quality is so variant, so we do not have much control over the output of the steel, quality of the output of the steel. So at source, quality control is required. In the informal market, it's very difficult. But in the how to bring it to the formal market, we'll talk about it. So the challenge is scrap, limited availability, weak formal markets, and the quality inconsistency. And on the demand side, MSME players or any other player does not get a quality assurance. We have seen that there is very limited linkages between the formal ELV market and the MSME industries, and price volatility is there. Now, it is a policy landscape that was also discussed earlier: national steel policy, steel scrap policy, and vehicle scrapping policy. These policies are there at the national scale, and some of the states have also brought in specific policies. It is extremely important to actually implement this, so that if there is a mandate that after 15 years a vehicle has to be scrapped, then it will actually get scrapped. That scrap comes into the steel market. And then the advantage of formal market, that is labor, be it labor condition, be it environmental advantage, that can be taken care of, and also segregation of scrap at source itself, and the steel players will get a better quality, defined quality scrap. So that's in brief, because I'm not getting into further details, and most of it was discussed earlier also. Just one more point. Going forward, one needs to look forward, look more seriously about determination of scrap quality. We don't have a solution for that. Segregation at source, of course, is one possible primary solution. To a large extent, it can be segregated, but still beyond that, it would be needed. Maybe we need to look at the possibility of AI-based segregation and all. We have to develop a technology, and some players are actually thinking about it and working on it. Green hydrogen, everything is covered earlier in much detail, so the only thing that I would like to focus on is, all of you also said that finally it boils down to what? Cost. The recently discovered cost in India was about 400k rupees per kg, versus the grey hydrogen costing much less than half of that. And our target is still half of that as of now. Cost has to be reduced. For that, renewable energy cost must be reduced. Today, the renewable energy at grid scale is costing about 2 rupees 57 paisa or so, the discovered cost. The minimum we had hit at some point of time was 1 rupee 99 paisa, but then the panel cost increased and all. We have to reduce, panel cost goes down, something goes down, efficiency of the panel improves, the cost of renewable energy has to go down. Another challenge is the hydrogen infrastructure, which we discussed. Now, another part about R&D and all we have discussed earlier, so I will not repeat. But on the market side, I would like to say something. That is, we have to develop a market simultaneously. One of the points that was discussed is the procurement obligation. Mine told about it. The procurement of obligation, certain part of government procurement could be green steel or hydrogen procurement obligation. That is good. And another thing is demand aggregation. If you look at SECI, if you look at EESL, what they do? They do demand aggregation, which drives the cost down. You know, solar energy, today we are talking about 2 rupees 57 paisa, and we are saying that it's high. You know, you must be remembering, 10-12 years back, what was the price of solar power? Do you remember? 18 to 20. Yeah. 15 to 18 rupees, even 20 rupees at some point of time. It is now 2 rupees 57 paisa, and the minimum we had hit was 1 rupee 99 paisa. So, procurement process, demand aggregation has driven it down. LED light at some point of time was costing high, but once EESL brought in the demand aggregation of LED lights, and today you know we all are using LED lights so happily at our cost has gone down. So demand aggregation is needed at a scale. If we procure hydrogen, of course it will also help in reducing the cost, in addition to improvement in technology both at the renewable side as well as the electrolyzer side. So in short, that I will not repeat something which has been stated earlier. Now, energy efficiency. For a MSME industry, energy efficiency is a low-hanging fruit. Interestingly, not much is happening over there. That's not the case with the large industries. Large industries, they have their own capabilities, technical experts who are kind of analyzing, advising, and they are taking action. But at the MSME scale, unfortunately, this is not happening. Both on the electricity side as well as on the heat side, there are inefficiencies. Some of the initiatives, of course, they were discussed in the previous presentation. There might be, of course, there are some reasons. One reason is that the investment for MSME, to make an investment, actually it's very difficult for most of the MSME. That's what the idea we get from them, because if you invest, you need the money back, and for them to bring in that money, to get into that risk mode is not that easy. But then we have to get low cost finance, and we need to have a mindset and a clarity that whatever money we save is a saving, and there is no need to pass on that money to the consumers. So that's my problem. So MSME players can do a lot in this regard in respect of energy efficiency. We as Switch On, we are happy to help them. If any of your contacts, they want support in terms of energy audit and advice on that, Terry is also actually working on it. We can also support such industries. Carbon capture and CCUS, no, nothing more to add. It was discussed in detail. Everything. So again, here the main point is cost, and that we have to work on it and reduce the cost. The last thing that in brief talk is the C-band. This is what the market is pushing the steel industries, the European market, in order to, their claim is that in order to make it equal, that their own industries are making carbon-free or low-carbon steel and all, and if somebody else brings in high-carbon steel, to make this equal platform, they are levying some penalty. That is the argument from EU side, but from our side, we have a legacy issue and they have a different legacy issues. They are not comparable. But in any case, it's a fact. While as a country we have rejected it, but the fact is that unless EU changes its position, we will face this. And we all know that there is a huge amount of export. Indian finished steel product export to the European Union increased from 10,000 crore in 2000 FY20 to 30,000 crore, more than 30,000 crore in 24. So the market is extremely important, and we will have to respond to it, reduce our carbon emission in the various ways that we have discussed now and in the last 5 days. I'm sure all those points are discussed. So that's it, because I'm not repeating points which have already been discussed. End of the day, we are also running late, but then at this stage, questions, yes please.
Yeah, I have just one question. I'm from JSWC. We have been exporting our steel to Italy. And there have been communication from Italy saying that you get certified on C-band. Certified on C-band. Show me your ISO 14064 or something. So we have been working on it. We are also responsible steel certified company. This responsible steel certification is not helping me in any way. At least Italy should have listened that yes, these are responsible steel manufacturers. We can accept their product. They are still bent on imposing 3% tax. So now they are saying 14% tax, 6% tax. I mean, it's so haphazard. There is no regulation and nobody is going to help us. So we are lone players. So any advice on that, please?
See, as a country, our position is very clear. You have seen that BRICS statement, and it has been very clearly stated that this is discriminatory. And if somebody, a powerful person, takes a discriminatory stand, arguments, logics doesn't work. Now of course, there would be two-pronged action. One, the diplomacy will have to work to the extent they can drive it down or push it down, because there would be retaliatory tariff, there will be those fights. That is one area. In the other part, whatever they are asking you to do for them to get satisfied, is hardly any other way other than to actually comply.
So we are paying the tax about their time.
So, but in any case, overall reduction, low carbon is a necessity in many other ways. So we have to continue working and reduce our carbon content, keeping the cost low. That is the crux of it. Now, how do we keep the cost? If we can effectively use renewable energy, if we can effectively use scrap, if we can effectively make it more energy efficient, okay, these are the solutions that one can look at it today. Now, tomorrow, once hydrogen becomes low cost, or CCU becomes doable, we'll see. And you are doing R&D, you will have more solutions.
I have one question. Is there any policy of government of West Bengal if I want to set up some rooftop solar panels and suppose I produce one to a power, then in which tariff they will take to the grid, or in which tariff they will provide me the grid current?
Right. As of now, the regulation says that other than agricultural consumer, every other category of consumer can set up rooftop.
There is any permission required?
I'll tell you the first of all the rule. The rule is that you can set up if your installation is within 5 kilowatt, you will fall under net metering capability. And if you go to more than 5, then you will be made under net billing method. The difference of these two is, in net metering method what happens, suppose you consume 100 units in a month. Out of that, you produce 60 units from your rooftop. Then 100 minus 60, 40. You pay WBSC DCL for 40 units only. 60 is forward. In net billing, what happens? You are consuming 100. You have to pay them for 100. This 60, what will happen? They will pay you, maybe they will adjust, but they will pay you at a predefined rate, which is today about 3 rupees 36 paisa. 3 rupees 36 paisa. So what happens, you see, in net metering, that's why it's a loss. It does not make sense.
The facility is, yeah, how much?
The rooftop solar Yojana that you have
One person
is in Gujarat, I don't know about West Bengal, that is calculated in bi-monthly position. So suppose in 2 month cycle, you consume 1000 units of electricity and you produce 800 units of electricity, so you will pay net 200.
That is net metering method.
Now, if you produce 1200 units and you consume 1000, then you are infusing 200 into the grid. For that, there is rate is 2 rupees 25 paisa. There you have loss because you are buying it. If you are consuming more, you are purchasing at 6 rupees or 7 rupees. But when you are selling, you are selling at 2 rupees 25 paisa.
I'll come to your point, but before that, let me
Most of the state have this model.
let me just complete what sir does. Sir, the process is that as far as CSC is concerned, in CSC, if you go to the site itself, it will this thing will happen. Here you have to go to WBSC and setting it up. I have up to 5 kilowatt load, and your connected load has to be, existing connected load has to be within 5 kilowatt. Okay, you cannot change the connection.
Suppose I have 10 kilowatts.
if you have a 10 kilowatt load, you cannot take a 5 kilowatt. You have to go for a net billing method. So that will
Policy is very complex in this case. Very complex.
yeah. Now coming to your point, you see what you said is correct, but there is a story before that also. When you are saying that your consumption is 1000 and you are producing 100, here also you are actually pushing power into the net. Because daytime, extra power, night time you draw it back. Alright. Now this drawal back, how much you can draw back, etc., is a matter of regulation which varies from state to state. In West Bengal, the rule is that it's an annual. You say Gujarat is a bi-monthly. In West Bengal it is annual, which says that up to 90% of your probably billing and annual billing from SCDCL, you can draw back. But if you, which means that there is a limit of how much you can push into the grid.
But
Beyond that, you lose.
But my pushing into the grid will be at a lower rate, and I'll like getting it, like if I'm push 900 units of
No.
that rate will
If
be
it is
balanced.
net metering method, it is just adjustment of units. If it is net billing method, then different rates. And that rate in West Bengal right now does not make sense for consumers.
Suppose I have a connection at home of 8 kilowatt connection, and so how much I can apply for the solar in West Bengal? Solar plant on the rooftop?
See the
Maximum how much can apply?
maximum is 8. You cannot go beyond it.
And minimum anything?
Minimum, of course, that is a sales question. I think they will not allow, if you are 8 now, they will not allow you to go for below 5. But you can ask this. I am not
Catch 22 there.
Minimum is 1 kilowatt. You have to. And if the your load is 100%, then less than 100% you have to apply.
No, my question was that if I have a connection of 8 kilowatt, can I install 4 kilowatt? My question was that.
Yes. You can install.
Huh? Because I don't want to go above 5 kilowatt in the net. I want to be net metering. I want to be net
In
metering.
that way,
Open, because this this problem what this sir is discussing is particularly bringing in West Bengal for the cold storage units. What happens during the winter time, even if they generate, they cannot consume. And if they send it into the grid, it's like a huge loss. So in that case, they install a zero export device. So what does this? Whatever the internal consumption, they will consume it, but they will not export a single unit to the grid. Because the moment they export it, it's a complete huge of loss. So they don't want to support this grid power. So there is a policy regulation kind of
More generation in daytime and no generation is in the evening is also an issue, na?
Exactly.
Yeah. So your answer is, as you said, it's possible. But then 4 kilowatt, to the extent it is beneficial. So when we plan for it, हमें थोड़ा calculation करना होगा. What is the right kilowatt we should use? Yes, please.
What is the current scenario of carbon capture in India? Do you have any data to show in different states and how they are doing or how much they are doing currently?
Now what Mayank showed, like at this stage it is happening at a kind of a pilot scale and all.
Only pilots, and it is very expensive also currently.
Overall it's expensive.
See, JSPL, they claim that they have a 2,000 or 3,000 ppb carbon capturing unit in their wood plant, but there are no takers of CO. Nobody is buying. Yes, they are converting to something or what they are doing exactly. They are not able to generate products. So they have a functional plant, but they are not using it. Because you know what? They are using JSPL. I'm not aware of the Tata Steel, what they are doing with their 5 kPd plant, 5 kPd, but JSPL, so they don't have plant and steel plant are not they are now not manufacturing the steel, but they are the plant ready. Technology is required. The fertilizer plants are already optimized for the current configuration. But when new plants, new fertilizer plants will come up with green ammonia as an option for intake, then CO2 will be required. It's a future solution.
Maybe Tata Steel is converting to ethanol.
Yeah, maybe.
But point is the ethanol cost is very low, less. The capturing is very expensive, but the cost of ethanol is very less. So if they sell it, they will not get profit.